Next heading, force between charges when some medium is present. Okay. When there is air or vacuum, what is the force formula, beta? 1 by 4 pi epsilon naught Q1 Q2 divided by
R square.
R square. Now what is telling between the two charges? This is a charge Q1 and this is a charge Q2. In between these two, we are keeping some medium. This is some medium of dielectric constant, say for example K. Distance between them is as usually R. Okay. Then force between the charges when there is some medium will be equal to 1 by 4 pi epsilon naught multiplied by 1 by K, some dielectric constant, multiplied by charges Q1, Q2 divided by R square. Here K is not constant, beta. What is K here? Dielectric constant. K is your dielectric constant. Am I clear? So when there is certain medium, this one is right now for me medium. This medium can be like kerosene, water, grease, oil, whatever it may be. So when some medium is being present, so force in medium will become how much, beta? You see? Now see this one. 1 by 4 pi epsilon naught into Q1, Q2 divided by R square will be what? Force in air. So I can write here force in medium is equals to force in air divided by K. Am I clear?
Yes, sir.
So now K is known as what? Dielectric constant, that is also equal to force in air divided by force in medium. That is also called as of your dielectric. Clear? So whenever there is a certain dielectric constant of the medium, then F is equals to 1 by 4 pi epsilon naught into 1 by K, Q1, Q2 divided by R square. K is your dielectric constant of the medium. Generally, K is greater than 1. Okay? Generally, K is greater than 1. And K is equals to infinity for metals. If he is using any metals, at that time you take K value to be infinity. Am I clear, beta?
Yes, sir.
Chalo. Now see here, force in medium law, epsilon naught into dielectric constant is also written as of your epsilon. Epsilon is known as what for me? Permittivity of medium. Permittivity of medium. Ante ఈ ఫార్ములాలో చూడు, ఈ ఫార్ములాలో in this one epsilon naught into K can also be written as, I'm writing here, you see, epsilon naught into K can also be written as epsilon. That means force in medium is equals to 1 by 4 pi epsilon into, this one is right now for me Q1 Q2 divided by R square. Q1 Q2 divided by R square. This is also the formula for force in medium. Am I clear? Am I clear?
Yes, sir.
That means dielectric constant K is also written as from this equation. K is equals to your epsilon divided by epsilon naught. That is permittivity of medium divided by permittivity of your free space or vacuum or air. This is also one of the formula for your dielectric constant. So how many formulas we got for the dielectric constant? You see once. K is equals to force in air divided by force in medium. And K is also equal to permittivity of medium divided by absolute permittivity. It is also sometimes called as what? Absolute permittivity. Am I clear? Done, beta?
Yes, sir.
This is very, very important formula you need to remember, beta. Okay. We got two formulas, one for the medium, another is for your air or your vacuum part of relation. Sure. Now this is very important. Keep this one as a note. Listen it very carefully. So what I'm telling is, like say for example, we got two charges here. Like say for example, this is your Q1 and this one is right now for me Q2. This is your Q1 and this one is your Q2. Distance between them is right now for me R. So what is the space between them? It is air. It is a medium అనుకుందాం right now for. Okay. So now two charges Q1 and Q2 are placed in a dielectric constant. I'll draw this one as dielectric constant. So medium is being present between this. Okay. What is the dielectric medium? K. So what will be the force between them better? F1 is equals to 1 by 4 pi epsilon naught into this one is Q1 Q2 divided by K into your R square. Antena?
Yes, sir.
Now, if we want the charge to be placed in vacuum, if we want the above charges, the above charges to be placed in vacuum. Okay, to have the same force, to have your same force as in medium. అంటే medium లో ఎంతైతే force ఉందో అదే force మనకు we need in right now for what? In your air or vacuum. Then what we need to do? We have to increase separation. We has to increase what? Separation between charges. ఒకసారి చదువు ఇది ఏం రాశాను నేను. If we want the above charges to be placed in vacuum. Now above two charges are where beta? In some medium. There is some medium. No, I don't want this medium. So when I don't want this medium, that means now these two charges Q1 and Q2 are being placed in air or vacuum. Now it is in air or your vacuum. Clear? Now distance should be changed. That will be equal to how much for me? R dash. అంతే కదా?
Yes, sir.
If we want the above charges to be placed in vacuum, we have to have the same force. It's important to have the same force as in medium. Then what we need to do? We have to increase the separation between the charges. Now I'm increasing that separation by R dash. Now given in the problem right now, when it is in vacuum, what is the formula beta? F1 will be equal to force will be same now. 1 by
Yes, sir.
4 pi. I'll take otherwise this one is 2. 1 by 4 pi epsilon naught into Q1 Q2 divided by R square or R dash square. This will be R dash square. This is my equation number 2 and above one is equation number 1. Given in the problem that they have same force. Given F1 is equals to F2. F1 is how much? 1 by 4 pi epsilon naught into Q1 Q2 divided by K into R square. That is equals to 1 by 4 pi epsilon naught into Q1 Q2 divided by R dash whole square. So anything is getting cancelled in this one beta. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, Q1 and Q2, Q1 and Q2 is getting cancelled. That means it is K into R square will be R dash whole square. Can I write like this? Am I clear? So what will be the value of R dash beta? R dash will be equal to am I audible beta?
Sir, there was some internet issue. I'm sorry.
Okay, fine. Are you clear with this condition once again? You see?
Yes, sir.
Yes, it is kept in medium. So when it is in medium, the force between them is 1 by 4 pi epsilon naught Q1 Q2 divided by K into R square. Now when it is kept in the vacuum, then F2 is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R dash square. Now given in the problem, F1 is equals to F2. Then 1 by 4 pi epsilon naught Q1 Q2 divided by K into R square will be equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R dash square. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled. Q1 and Q2 will also get cancelled. Remaining is K into R square is equals to R dash square. So R dash will be equal to how much for me beta? R into root K. Can I write like this? So the new separation should be increased by how much beta? R dash is equals to R into root K. Am I clear?
Yes, sir.
So what I can tell right now, a distance of R of medium or of your medium is equivalent to చాలా సార్లు అడిగాడు ఇది. It is equivalent to what? A distance of R into root K of vacuum. Okay. Then what is telling? A distance of R.
Sir, you're not audible.
Yeah, just a moment. Now I'm audible.
Yes, sir.
Sure. So now what is the condition I have written right now here? You see, R dash is equals to how much for me? R dash is equals to R into
Distance of
root K. What is this one? A distance of what? R of your medium is equivalent to what? Is equivalent to a distance of R into root K of your vacuum. Clear? See this one. When a slab, think twice, of thickness T is placed between charges. Okay. T is equivalent to T into root K of your vacuum. Can I write like this?
yes, sir.
What do you mean by this one? When a slab of your thickness T is placed between the charges. Now T is equivalent to T into root K of your vacuum. And let me draw it with an example. Here we are having two charges. This one is say for example Q1 and this one is say for example Q2. And in between there is a slab here right like this. Okay. Thickness of this one is equals to your T. Distance between them is say for example D. Now if I remove this one, then in vacuum, what will be the distance better? You need to increase the distance. This is your Q1, this is your Q2, and this is your vacuum. And here there is a medium when it is in medium. Now you are increasing the distance. When you increase the distance, what will be the remaining distance better? You can write here right now. From the D, you need to remove T. So it is D minus T plus replace the T by your T into root K. This will be the distance in vacuum. అర్థమైందా? అర్థమైందా?
Yes,
ఈ మీడియం లో థిక్నెస్ టీ ఉంది అనుకోండి, ఈ టీని తీస్తే అప్పుడు ఏమైపోతుంది? డి మైనస్ టీ అండ్ ద డిస్టెన్స్ షుడ్ బి ఇంక్రీజ్ బై వాట్ బెటర్? టీ ఇంటూ రూట్ కే. Isn't that
yes,
is the force in your medium?
yes,
Am I clear?
yes, sir.
Sure. Take this question and give me the answer. Find net electric force on charge Q in the given diagram. Okay. And take 1 by 4 pi epsilon naught as 1 by 4 pi epsilon naught into capital Q into small q divided by d square. Whenever it comes like this, you take that one as f naught. See the first diagram better. ఆలోచించి చెప్పు answer. Here we are having a charge 4q. Here we are having a charge 2q. Here we are having a charge of small q. And here we are having a charge of capital Q. And distance between them is from here to here. This distance is right now for me d. This distance is also equal to d. And this distance is also equal to your d. Tell me, what will be the force on small q? ఆలోచించి చెప్పు. What is an electric force on small q due to 4q? Then what is the electric force on q due to your 2q? First one, due to 4q. In which direction will exert the force better?
I'm sorry, sir.
4q, what will be the direction of the force 4q on your q? What is asking the problem? Find the net force on the charge q. Q is small q is our reference. That means 4q is exerting the force on small q. 2q is also exerting the force on small q. And capital Q is also exerting the force on the small q. Isn't
Yes,
it?
sir.
Now 4q is more than small q. So this will exert the force in this direction. This is right now, say for example, F1. Ante kada?
Yes, sir.
Now that F1 will be equal to how much for me? In positive x-axis, F1 is equals to 1 by 4 pi into 4 times of capital Q into small q. Distance between them is how much better? D plus D. That will be
D.
equal to 2D whole square. This is towards which direction beta? Towards right. This is towards right. అంతే కదా? అంటే
Yes,
F1 is equals to how much for me? 1 by 4 pi epsilon naught into 4 times of capital Q small q divided by 4 times of your d square. 4 and 4 will get cancelled. So this can be written as F naught. అంతే కదా?
yes, sir.
Towards right. అర్థమైందా?
Other sir.
And tell me 2q will be equal to how much right now for me?
1 second.
Which direction it will be? Tell me, friend. Well, left.
Right only, sir.
Right only. Very good. Because 2q is more than small q. So this is also
Yes, sir.
in the same direction. So how much is
Sir, I think the answer is 1 by 4 epsilon naught into 1 by 1 q or capital Q small q by 2 d square.
by 2d square? It
Sorry.
is only d now.
Okay.
Distance between 2q and q is how much for me? D only.
D. Yeah.
So it will be equal to how much for me? 1 by 4 pi epsilon naught capital Q small q is F naught. So this will become for me 2 times of F naught towards right. Done? Am I clear?
Yes, sir.
Now tell me about capital Q. How the capital Q will exert the force on small q and in which direction?
It will exert in left
Very
side,
good.
left
The capital Q is more than
direction.
small q, so it will exert the force F3 in the left direction. So what is the force here right now? This due to capital Q, F3 is equals to 1 by 4 pi epsilon naught into capital Q small q. Distance between them.
4d square.
Why 4d
So
square?
only
Small
d square.
capital Q. How much it is? D only, na?
D, sir. Yeah.
So this value will become how much for me? F naught. This one is
Epsilon.
towards left. Alright?
Yes, sir.
Net is equals to how much? Resultant force is equals to F1 plus F2 plus F3 is in opposite direction. Minus. So it will be equal to F1 plus F2 minus F3. Can I write like this? F1 is how much for me? F naught. F2 is how much for me? 2F naught. F3 is how much for me? F naught. That means it will be a 3F naught minus F naught. So it will be how much for me? 2F naught. In which direction? Which is dominating, right or left?
Right.
Very good.
Right.
Right is dominating. So it will be 2F naught. Right. Which in the
Yes, sir.
golden area? Sure. One more example. Say, for example, charges are kept like this. This here is 9 cube. Here it is right now for me cube. And here it is your 16 cube. Distance here is right now for me 4D. And this distance is right now for me 3D. Clear? I need the net force on small cube. So, just due to 9 cube. You tell me. 9 cube will exert the force on cube in its direction. Downward direction like this. F1.
Yes, sir. Downward.
And 16 cube will exert the force on the small cube in this direction. This will be equal to F2. So F1 will be equal to 1 by 4 pi epsilon naught into this is 9 cube into small cube divided by 3D whole square. So this will be equal to 1 by 4 pi epsilon naught into 9 times of capital Q small q divided by 3 square is 9 into your d square. 9 gets will cancel. This will be equal to F naught. Clear? Then due to 16q in the Sunjapo, F2 is equals to 1 by 4 pi
One.
epsilon naught into this one is 16 cube into small q divided by distance between them is 4d whole square. So that will be equal to 1 by 4 pi epsilon naught into 16 capital Q small q divided by 4 4s are this is 16 into d square. This 16 will get cancelled. So again this will be equal to how much for me beta? F naught.
F1.
So F1 is equals to F naught. F2 is also equal to F naught. And two forces are at 90 degrees to each other. How do we calculate the direction? Parallelogram law of vector addition you can use. The resultant of this one will be equal to FR, isn't it? Now tell me, parallelogram law formula FR is equals to under root of your this is F1 square plus
F1 square.
S 2
F2 square plus 2
into
F1 F2
cos 90.
cos 90.
Cos 90 is 0. So this total term is 0. That is equals to under root of F1 is equals to F naught square. F2 is also equal to F naught square. So this will be equal to how much for me? Under root of your 2 times of your F naught square. So it will be equal to how much for me? Root 2 into your F naught. Clear?
Yes, sir.
Or tell me what will be the angle beta? If it is making some angle here right now with x-axis theta. He is not asking, just I'm telling you. Tan theta will be equal to how much for me? Y by x. Y value is f naught. X value is also f naught. So f naught gets cancelled 1. So tan theta is equals to 1 and theta will be equal to how much for me? 45 degrees.
What?
Clear?
Yes, sir.
Start. Concept of neutral point. are null point. Clear बेटा? అర్థమవుతుందో చెప్తుంది?
Yes, sir. వాయిస్ కొంచెం లో ఉంది సార్.
ఏమన్నా
వాయిస్ కొంచెం లో ఉంది సార్ ఇందాక.
వాయిస్ స్లో
Now
అవుతుంది.
it's okay.
Me too. Then I'll use the speaker otherwise from next time. So, see the first one, ready? Here it is plus Q and here it is plus Q. Both of them are positive. Okay. What will be the force between them? Attractive or repulsive?
Repulsive.
Will be your repulsive. Somewhere at this midpoint, I'm keeping a third charge. That is plus Q. Okay. Now tell me what happens. Whatever the charge, the first one is exerting on small q. The second one also will exert the same force on that one.
Yes, sir.
So then the forces are same actually on this one. Like say if this is your A and this is your B. This is the force exerted by A here, and B also will exert the same amount of the force here, right? That means FA is equals to FB. That means charge is not moving. So can I say that plus Q is in stable equilibrium? అవునా కదా? Because both
Yes,
of
sir.
them are exerting the same amount of force. It is not able to move. So it will not move. So if it is not moving, then it will be in what type of an equilibrium? Stable equilibrium. Am I clear?
Yes, sir.
Now see, same situation. If I keep a negative charge, now think and tell me what happens. Here I am taking plus Q, and here also I am taking plus Q. And in middle, if I am taking right now for me minus Q, it is exactly in the middle. Now tell me what happens.
So then also it will be stable equilibrium.
Hmm?
I think in that case also it will be stable equilibrium because equally attracting force will be there.
Middle charge is negative,
Yeah.
isn't it? Think. Plus Q and minus Q.
But then at the ends it is still plus q and plus q. So equally they both will attract the minus q.
This minus Q will try to drift towards A, or it will try to drift towards your B, because it is not positive now. So negative means it will try to get attract. It will try to get attract towards the plus Q, or it will try to get attract towards your plus A, isn't it?
Yes, sir.
So
Yes,
it
sir.
will be highly in unstable equilibrium. Minus Q is in unstable equilibrium.
But plus q and plus q are equally at, will equally attract the minus q also.
We are your father and mother. You are exactly center. If someone asks you, whom do you love more? Then you will be in a confusion mode.
Yeah.
And in that situation, what will be your answer? You will be a neutral only, na? You might be
Yes.
inclined towards your father. You might be even inclined to your mother. But still, you
Yes, sir.
unstable equilibrium. You will be still in a confusion mode. Am I clear?
Yes, sir.
Isn't it? Like say in first situation, there is father and mother. isn't it? And you have got your friend, and your friend is sitting in middle of them. If you ask who is your favorite, so what will your answer? Neutral. He doesn't know about your father and mother, so he'll be keeping quiet, isn't it?
Yes, sir. Understood.
Got it? Chalo. Now tell me
Yeah.
this question. Think and tell me. Now this one is right now for me here. One is right now for me negative charge. And here is also your negative charge. And in the middle, we are keeping minus q. Okay.
Then it will be stable like this.
Why stable? Like say here A and B, isn't it? And on both the side, it is the photo of your mother only, isn't it? At A, it is your mother, and B is also your mother. And both of them are in photo. If you are sitting in middle, and if someone asks you, whom do you love more? So obviously your answer is both. That means you may either be at B or A. It will be fun and the same answer. You will be not in any confusion. You will say that I love both of them, isn't it?
Sure.
Both the photos of your mom only. So you say that obviously they are like. So you will be not in unstable. You will be obviously in what? Stable equilibrium. So can I say here right now minus Q is in
Stable.
stable equilibrium. Antena?
Answer. Yeah,
Chalo.
I
Now let's
got it.
question and think and tell me. Now here there is a negative charge. Here there is a negative charge. And in the middle there is a positive charge plus Q.
It's unstable.
Obviously it is unstable. Why? Because again same. This is A and this is B. Father and mother. You are standing in middle. So you will be an unstable to identify who will you love more. So that is the reason I can say right now here plus Q is in what type of equilibrium? Unstable.
Unstable equilibrium.
Hmm. Got it?
Yes, sir.
Tell me the answer for this question. Here there is plus Q. Here there is plus Q. And in the middle there is minus Q by 4. Stable or unstable?
It is. It is
Q by 4.
unstable. It's unstable.
All of them are unstable here.
Yeah, sir.
All charges are in unstable. Previously, both of them were same, and magnitude of the small q is also same. Now here plus q, and minus q. Am I clear?
Yes, sir. I did.
Sure. This one you tell me. Now here it is minus q, here it is minus q, and middle it is your plus q by 4. Again, all charges,
Again, all are unstable.
all charges are in unstable equilibrium. What an idea?
I'm sorry, sir.
Then,
Yes, sir.
sure. See here. This one is q1, This one is Q2. Distance between them is L. Okay. Somewhere in between them, there is a neutral point. Q1 and Q2 are same side beta. Then where should the third charge will be kept in between so that it will be in equilibrium? Okay. And third charge should always be kept nearer to the smaller charge in between the two charges beta. Let's say if Q1 is lesser than Q2. Q1 is lesser than Q2. Then a third charge will be kept here, which is nearer to the smaller charge. So obviously remaining distance is L minus of your X. Am I clear? Now the question is, where should the third charge should be kept so that the system will be in equilibrium? Am I clear?
Yes, sir.
So how many charges are there totally? Three charges. One is Q1, another is Q2, and distance between them is your L. Now the condition is where should a third point charge be placed between them so that it will experience no force. Okay. Now
Okay.
Q1 will exert the force on small q in this direction. Let's say this is F1. The same way this will also exert the force on this one is F2. Now tell me what is F1? F1 is equals to 1 by 4 pi epsilon naught into capital Q into Q1 divided by x square. Clear? The same way F2. F2 is also equal to 1 by 4 pi epsilon naught into capital Q into Q2 divided by L minus of your x whole square. Isn't it? Since net force is 0, F1 must be equal to how much for me? F2. Since F net is equals to 0, that means system is in equilibrium. System is in equilibrium. Whenever we use the word equilibrium, that means the net force acting on the system is 0. Like we write like this. F net is equals to, for the given diagram, it is F1 plus minus of F2. So it will be your F1 minus F2 and F net is 0. So therefore, we are getting F1 is equals to F2. So F1 value is how much here? 1 by 4 pi epsilon naught into capital Q into Q1 divided by x square. That is equals to 1 by 4 pi epsilon naught into capital Q into Q2 divided by L minus of your x whole square. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, capital Q will get cancelled. So it is Q1 divided by x square is equals to Q2 divided by L minus of your x whole square. Clear?
Yes, sir.
Now if I need to calculate the value of x, so I'll take all the charges at one side. Q1 divided by Q2 is equals to x square divided by L minus of x whole square. So this can be done as of your x divided by L minus of your x. This is a total whole square. If I remove the square, this will be equal to Q1 divided by Q2. It is equals to x divided by L minus of your x. So this will be equal to how much for me? X by L minus 1. Clear?
Yeah. Yes, sir.
So minus 1 if it comes here right now, this value will be equal to how much for me? Q1 divided by Q2 plus 1 is equals to how much for me? X divided by L. So what is the value of X? What is the value of X? X is equals to
Eh,
X is equal to how much for me? Under root of Q1 divided by Q2. This one is right now for me plus 1 into your L. Done?
Sir, am I audible?
Yeah, audible.
Eh,
Done, beta?
Yes, sir.
You can still simplify this one. What is the value of your X? Can it be written as Q1 divided by root Q2 plus 1 into L is equals to X? Then beta,
Yes, sir.
now tell me what is the value of your x in this one. X value is equals to your root of your q2 divided by root of your q1 plus 1 into your L part of relation. Then
Yes, sir.
I'll rewrite like this and make a shortcut formula a little bit larger. X is also equal to, you can write this one as root of your q1 divided by root of your q1 plus root of your q2 multiplied by L. Can I write like this?
Yes, sir.
Will be getting the same formula.
Yeah.
Q1 is smaller charge here. Q1 is equals to smaller charge. And Q2 is your larger charge. Clear?
Yes, sir.
This is the shortcut formula you need to remember. When two charges are being given, where should be the third charge be kept in between them? Like say for example, tell me the answer for this one faster. If I'm having two charges here, one is plus q, another one is 4q. And in middle there is a third charge kept q at a distance of your x. Find x. Tell me. X is equals to, what is smaller charge? Root q
Plus.
divided by, this is root q plus, this is under root of 4q into distance between them. Distance between them is say for example L into your L. So this will be equal to how much better? It will be equal to root q divided by, this one is right now for me root q plus root 4 is nothing but 2 into your root q.
Okay.
Isn't it?
Yes, sir.
So everywhere root q will get cancelled. Isn't it? Because it is root q
Yes,
divided
sir.
by, here root q is common into 1 plus 2 into your L. So root q will get cancelled. So this will be equal to how much for me? L divided by 3.
Yes, sir.
Got it?
Yeah, got it.
Sure. One more example. Tell me faster. Now you do it out. Now we are having
Okay.
charges. This is right now 4q. This one is say for example 9q. Okay. Now I need the distance. Question is find distance from 4q where a third charge can remain in equilibrium. Can remain in equilibrium. Tell me. Third charge
Sir,
can
what is the
x.
distance?
It is your
L?
x. Total distance is not given. I'm taking it as of your L. So this will
Okay,
be
sir.
to L minus of your x. So use the above formula and tell me the answer fastly.
1 second, sir.
Equals to, yeah, go. I'll give the options for you.
Second option, sir.
Very good. Got it now? Root of your 4q divided by root of your 4q plus root of your 9q into your L. Root 4 is how much for me? 2 into root q divided by, here root q is common into root 4 is nothing but 2 plus of your 3. Root q will get cancelled into L. So this will be equal to how much for me? 2L divided by 5. And then,
Ante, sir.
sure. This was the formula when beta? When both of the charges were positive. Q1 and Q2, both of them were right now for me what? Positive. This one was positive. and this one was positive. If we say, sir, if one is negative, one is positive, then what will we do? Same formula, but just change the condition. See in this situation. We are having two charges here. One is minus q, another one is plus q. And distance between them is again right now for me L, or it may be R. Whenever it is negative charge beta, the third charge should be kept nearer to the smaller charge and it should always be outside. This will be your X. Got it?
Okay, sir.
Q1 and Q2 are of opposite sign, then third charge will be in equilibrium is nearer to what? Smaller charge and outside the line joining the two charges. You need to remember this one. Formula is again same. I'm not deriving that one. Directly I'm writing here. X is equals to, what is the formula? Root of your Q1 divided by, this is root of your Q2 minus root of your Q1 multiplied by your L. Clear? And Q1 is always smaller charge beta.
Okay, sir.
X is right now from where? From smaller charge. So this is your formula. Clear?
Okay, sir.
Opposite charges. Let me give you an example. We'll get a clarity. One is 9 cube. Another one is plus cube. Distance between them is L. Tell me what is the smaller charge here?
Minus 9Q.
It's 9 cube. Smaller is what? Plus q or minus 9 cube?
Minus 9Q.
How?
Because it is having a negative charge. Okay.
It will be plus q, na beta.
Okay.
Somewhere here it will be your x third charge. This is your x. So that means x will be equal to, it will be root of your q1. That means root q divided by q2 is right now for me under root of your 9 times of your q minus root of your q into your L. So that will be equal to root q divided by root q is common into root 9 is nothing but how much? 3 minus 1. Root q will get cancelled. This one is into L. So it is L divided by 2. Got it?
Yes, sir.
Sure. Take some questions as homework better and try to do it out. First one. Here it is plus 25 cube minus 16 cube. Distance between them is L. So x is equals to h. Okay. And one more question. This one is plus 16 cube. This one is plus 4 cube. X value is equals to how much? Just put up.
Yes, sir. I'll
Will
do
be
it.
third charge we kept in between them. Yeah.
Yes, sir.
I mean plus 25 and minus 16, which is smaller?
Minus 16.
Minus 16, very good. That means
Yes.
somewhere outside here, there should be a charge q and this should be the value of x. You can calculate that one. Here both of them are positive. The charge will be kept where beta? Nearer the smaller charge into distance of your x. The remaining distance is L minus x.
L minus X.
Yes,
Yes, sir.
sure. ఈ రోజుకి ఇది చాలు. Tomorrow we'll try to continue with some more problems on Coulomb's law, both in
Okay, sir.
little bit of your higher level with applications of your buoyancy, fluid mechanics, and little bit of your Newton's laws of motion application in the Coulomb's law. Then we'll try to start with your electric field. రేపు కూడా క్లాస్
Okay.
ఉంటుంది, 8 o'clock. ఓకే,
Okay, sir.
చలో టేక్ కేర్. ఏమైనా అర్థం కాకపోతే ప్లీజ్ లెట్ మీ నో, ఐల్ ట్రై టు హెల్ప్ ఇట్ అవుట్. క్లాస్ నోట్స్ జాగ్రత్తగా చదువు, అండ్ ప్రాబ్లమ్స్ ఐల్ ట్రై టు సెండ్ యూ వన్స్ యూఆర్ క్లియర్ విత్ యువర్ Coulomb's law. ఓకేనా?
Okay, sir. Sir, you told you'll be recommending few books to
Yeah,
buy.
that one, but I'll send you. Okay,
Okay, sir. Okay, sir.
bye.